Afternoon. Let's just get my desktop showing. Hopefully you can now see a desktop. Running a bit slow, but so good afternoon and welcome. It's Friday afternoon, so not a great time for a session, but thank you for staying on and I hope you enjoy it. I'm hoping that you can see what I can see. Sam, can you let me know if that's not the case? So the session is common GUI patterns. My name is Paul Leslie, work for QA as a principal technologist and involved entirely in the sort of .NET development area. I've been in development all my life and moved into training a few years ago now, 15 years ago I think, and enjoy it just as much. So hopefully so will you. Off we go. First, some housekeeping stuff. Oh, firstly, if my voice fades or comes back, can you let Sam know and she'll pass it on to me? It happened yesterday and I don't know why, and I put the microphone a bit closer to my mouth, well, as close as it can go now, so hopefully we'll be okay today. So if you've joined previous sessions, you'll know that there's an email address set up for comments about the technical week itself, and then my personal email, or my QA email I should say, is down the bottom, and if you've got any questions after the session, please feel free to let me know. During the session, as Sam said, the chat tools for that purpose. So the things that we'll be covering. First of all, just an introduction to patterns. I remember when I first started patterns, so 95, it was the design patterns book that got me started. They were just baffling, and fortunately I had a colleague who was one of those people who could stick a book under his pillow at night and wake up in the morning understanding it, and he took the time to talk me through a few, and then suddenly I realized what I'd been missing. And so introduction to patterns, a bit of unit test, so if you like my little rant session there on unit test, and then the bulk of the session would be on to the four major patterns, of which the first one, the smart client, is possibly something of an anti-pattern. Hopefully the remaining three ones you've heard more than once, and so I'll hopefully give you the inside story on those. Off we go. So what are patterns? Just a little warm-up to get us started. This is one of the commonest patterns in the world, and looked at like that, it's probably, I wonder what on earth that is. But can you see, if we just refactor it somewhat into that sort of style, suddenly there's a whole raft of understanding that comes with it. In other words, it's not any different from the previous one. It's just that what we've done is we've put it into, if you like, a sort of third normal form, a standard form, where I don't need now to explain what the reaction, the responses and reactions are between the various controls, because I think it's embedded in every sort of 2-year-old's brain by now. Or another one, something that I know all of you will be very familiar with. I've got a British and American version here, and looked at like this, you probably think, I wonder what that is, but hopefully that will help a bit. In other words, you might call it the driving pattern. I don't own a BMW myself, but I understand that they don't actually have this brake pedal here, it's just the accelerator. But can you see that if every manufacturer decided to have a different approach to how they decided to control, steer, accelerate and brake a car, there'd be no such thing as the car hire industry. You couldn't get into any car and just drive it. In other words, patterns are a way of expressing things that just work and giving them a name and giving them a whole level of understanding that sort of goes with it. And the deal with patterns is that you don't sort of drag and drop it onto your code. It's more like you drag and drop it onto your mind and then bounce what you've got in your mind against the problem to hand and see if it can help or not. It's not like a sort of pre-canned solution to every problem. So they really are a sign of engineering maturity. I remember when I was at college, looking at the King's College Chapel there, the inverted sow, and the guys in the, I think it was 1400s is when it was started, took 100 years to build. They were aware of this middle third instructions, that you had to get the load within the middle third of the cross-sectional area, otherwise the thing would fall down. And that's what these pillars are for on the top. And took these pillars off here, then the whole chapel would just collapse. And that was something they became aware of. got embedded into the way that structural engineers thought. If you're building a house, the pattern there is to do different diagrams for different views of the house. If you're designing car bodies, then there's types of chassis design and types of monocoque design, but not a whole sort of plethora of variations of those. And of course, sort of Tesla's AC power supply redistribution system replacing the old DC power supply system. Why do we have 3-phase? Why not 5-phase or 7.5 phase? In other words, what patterns are is they're ways that have been found to have been useful pragmatically. They're not academic things, they're pragmatic. And somebody's then given it a name and documented the sort of things that sort of interactions between the elements of the pattern, and that then becomes a cornerstone for how others can reason about related problems. In other words, they themselves become good practice. So they're to stop you doing this, really. Bit of an exaggeration of the Swiss Army knife, which I must admit, I always thought the Swiss Army knife. I see it, somebody says, keep going very quiet. I'll put the microphone a bit closer, and I'll try and speak up a bit like that. Hopefully that's a bit better. So the Swiss Army knife, actually, and I personally used to sort of poke fun at it for many years as being a good example of incoherent software or incoherent design. But in fact, every Swiss mail is issued with a machine gun, and the Swiss Army knife is the ideal tool to maintain every maintainable aspect of that machine gun. So, but I guess with the one shown here, you never attempt to get a Boy Scout out of a horse's hoof with that. You choose the appropriate tool for the job. So that's what patterns are intended to do. It's to steer you into a way of, if you like, a sort of starter guideline of good design, designs that have worked in the past. A visual metaphor for you to help sort of embed what's going on. But you've probably heard of the term separation of concerns. That's what it's all about. Is to have software where elements are separated from others, such that we don't get a problem manifesting itself in many, many areas at once. And the metaphor I've used in this particular diagram here is Italian cuisine. That in the 70s, we got rid of spaghetti. That we had a lot of spaghetti code on the go, and the creation of the sort of structured programming idioms allowed us to get into, and Massey Schneiderman diagrams, I remember, get us into a mode of thinking where go-tos were just evil. But we want a slight advance on that. What we're really after is maybe a bit of ravioli. Our software goes into chunks, which have connections within the bits of ravioli and minimal connections between the ravioli. And I guess that the overall aim is to make stuff into lasagna where you've got layers of software like that. So maybe that metaphor will help in where we're going. So on to the unit test story. And I thought I'd Google a few images of unit tests. And sure enough, the ones I got, I think, told exactly the wrong story. But I know it's spelt unit test, but you should actually pronounce it design, because that's what it is. Unit test is almost as a spin-off benefit of testing tool. So it doesn't really belong in this stack here of testing idioms. It's really a design tool. Another diagram I found on there, which I thought was quite good, so I put it in anyway. It turns out it's a product that helps you produce unit tests, but beyond that, I don't know anything about it. It just looked pretty good. And then my memory of unit tests, which is much more of a sort of spreadsheet example here, where for me it was a mechanism to say to the project manager, look, you can see I've tested it. I've put a tick in the box. Now will you go away? And I'd completely missed the whole thrust of what unit test was about. As I say, unit test is a vehicle that liberates you to actually design. And if you might start off with a pattern, but unless you have some sort of mechanism to keep you constantly reviewing how you're doing against your original design vision, then you're going to drift off. And unit test helps you with knowing whether you're on track still or drifting off. So a lot of people say, well, it's tested software, so why do I need unit tests? So I'd like to address that before we hit the patterns proper. And for me, software that's tested is not the same as unit test. Software is tested is like the state of the software. Yes, it's been through these tests. Unit test is a process. It's really a mindset where you're constantly looking at what you're doing and trying to elevate yourself above the level of the code and see the design view of what's going on. You may have heard of a product called YURI Automation. It actually came out with all the other WXF type of products, the WPF, WCF, the WWF, as it was originally badged, which is not the World Wildlife Fund nor the World Wrestling Federation, but the Windows Workflow Foundation, now rebadged as Windows as Workflow Foundation. And YURI Automation came out with them, but for some reason never achieved the same sort of level of public awareness that the others have got. Maybe it should have been called YURI Automation Foundation or something like that to give it a bit of standing. And what it is it's a way of testing your software from the front end. Works for WPF and Windows Forms. I've got a couple of examples coming up, so let me just show you what's going to come up. I've got an application on the test. I've got a couple prepared. One's a sort of homegrown one, one's the Paintnet. And what you can do is construct, like on the left here, construct an automation client that can wind up an instance of your application under test and then fire certain things through its user interface to it, look at the resultant values and confirm that it's what you get. That what you get is what you expect. In other words, a complete end-to-end test, which is brilliant. It's not unit test, but it's a complete end-to-end test. The sort of software that would involve would be like this, and I was expecting it to be quite awkward to understand, but actually my experience of the YURI Automation is that once you're into the flow of it, it's really not bad at all. So if you haven't heard of it and you're doing Windows Forms or WPF, then have a look at the YURI Automation. I'll wind it up in a second and you'll see it in action. So I couldn't fit all three onto the same PowerPoint slide, so they're ready to all go together, those three things. Starting with the application, selecting a control, and then setting a value on it. By the way, this pattern that's mentioned here is not a GUI pattern. These are the patterns, the protocol of how you talk to particular controls. So let me show you an example, a couple of examples of this. What I've got over here. So I'm using Visual Studio 2013 and running on .NET 4. And we'll be doing C#, even though this one has a VB variant as well. So here's the code I just showed you in its fullness. And this exercise is the front end. It's a homegrown application, a little calculator application here, which hopefully is sitting in the debug bin folder. Where are we? Open folder. Sorry, bin debug folder. So here the calculator X is going to exercise, and can you see you can put in some numbers into here. Nothing very grand going on. Select an operation, and when it calculates the result of that, and so you can check that that is the combination of those, which is correct. How can we automate that? Well, we can automate it with the YURI Automation. So if we run it, you'll see a console window occur, pop up here, hopefully. And first of all, it'll find the calculator application. Then what it'll do, it'll put numbers into the text boxes, the two text boxes at the top. It'll select an operation. I think it's probably divide. So it'll put 200 into one box, 100 into the next box. It'll select the divide, and it'll wait a second between each of those so you can see what's going on. And then finally, click the calculator button, look at the resultant value, and make sure that 100 or 200 divided by 100 is 2. So I'll put a number in once I move this out of the way, and that's why I put a a holder there. That'll put a 200, 100, select a divide, get an answer, and then check that things are good, and then close down the application. So if you haven't seen that before, then it's a brilliant little tool. I use it a lot for connecting applications together, but it's not a design tool. It's not a unit test. I actually came across another one, which is very visual, so I thought I'd show it to you, which exercises Paint.net. By the way, all of the demos that you see here and the things that I create will all be available from a download site. Sam will be able to sort of distribute details of that if you haven't already had them. So here's one that operates on the Paint.net. And what it does is it winds up Paint.net, so it finds it in program files, winds it up, and then takes control of the user interface and draws a nice little spirograph. So it's initiated by a WPF program, but that's pretty much the end of the WPF. Now it's over to driving the Paint.net. And those of you of a certain age will remember little toys that you got at Christmas that did this, the spirograph. And that's done by YURI Automation. That bit's done by me because I didn't quite complete the closing down. So as I say, both of those will be available in the download. So that's YURI Automation, which is, as hopefully you've seen, doesn't require you to have, it doesn't require you to look at the design of your program. It's just, is it correct or not? Does it satisfy put these stimuli in, do I get the right stimuli, do the right responses out of it? If you're interested in how, for instance, Paint.net was done, there's a little utility called UI Spy. I think it's now replaced by one called, the name escapes me for the moment, Inspect, I say inspect.exe, where you wind up UI Spy and then you can select an application and it'll disassemble it for you like this into its controls. You can either access controls by an automation ID or by a name. And that's exactly how we did the calculator and the Paint.net. And just as a credit, I didn't do the spirograph myself. There's a guy called Samuel Jack, and there's his blog. So if you like what you saw there, then he was the guy who put it together. Okay, so what does UnitTest offer that the full end-to-end testing doesn't offer? Let's have a look. So just to prove that I do practice what I preach, I built a chess program some years ago now, the days of Windows Workflow 3, in fact, and had UnitTest in place to test the workflow, because I found myself getting just into a mess with the workflow and needed something to help me out of that. So I can show you that. By choice, I used NUnit, although for me the difference between NUnit and MS-Test is minimal. There's one little thing which hopefully I'll be able to show you, which for me tips the balance very slightly in favour of NUnit. But here we've got it's a Windows Form application that runs a chess game, and I've got some user interface tests here. And if we run those, hopefully they should still pass. They did last time I tried. So the reason why it takes a little bit of time, ideally UnitTest should be just instant, but the reason why it takes a bit of time is because the workflow is asynchronous and you have to give it time to complete. So these, I know, helped me massively understand what the problem situation that I could then implement in Windows Workflow. And that's what UnitTest gives you, is a view into what the business problem is. It's strange, and if you haven't come across UnitTest before, it's strange that such a small effort on or a small element on one's part. I use the word effort. It does take effort to produce UnitTest and to maintain them, but such a small tool like this has such a massive leverage. And we go back to the beginning. I didn't mean to do that. Resume slideshow. How about that? And I don't know if you noticed, because I didn't show you, let me show you, was that it's actually using some mock objects here. So you might have heard of the term mock objects, in which case I'll hope you'll bear with the others who haven't heard the term. What does it mean, this mock object? Hopefully you've seen this type of syntax before, known as lambda syntax, and it's a very common way of writing C# nowadays. It's like you plug in a little procedure here, and you extract just the essence of it to put in there in line. Let me explain, though, what mock objects are. First of all, a bit of slide stuff is that here is my unit test, testing my workflow. And this workflow itself called out to the business logic again in order to get a result to pass back to the workflow, so I could then figure out whether the workflow, unit test, whether the workflow would work correctly or not. And at first sight, it would appear, well, you can't even begin to test the workflow until the business logic is complete, because otherwise this software wouldn't work in here. And the business logic can't be tested until the data access is complete, until the database is complete, until the database is populated. So can you see that it would appear to be the case that you can't begin to unit test anything until the whole project is finished, which is rather too late, because unit test is the thing you do before you write an operational line of code. So how does this mock object solve the problem? What I'll do is I'll show you a little example that actually I use in the course and build it up for you so you can see what mock objects are. So what I've got here is a little program called Greeter. Come back to this in just a minute. This is the test where I've got a message of the day class. And this message of the day class, either, I think I must have had a flashback to the Hello Hello program of the 80s and 90s, the French policeman, or the English airman, wasn't he, as a French policeman. So if it's before midday, good morning, otherwise good afternoon. And we want to be able to test this. So I happen to have put the tests into the same DLL, which I've done here. Probably operationally, I'll put them into a separate DLL, and certainly if you're using MS Test, then we'll go to a separate DLL. And so I've got a couple of tests here, one to test the morning, one to test the afternoon. And of course, if we run this, what's going to happen, hopefully, some of you will have spotted this already, what's going to happen is that the morning one will fail. And the reason why the morning one has failed is because, where am I missing the day? I have a dependency on the system clock. What I need to do is to take that dependency out such that I can take control of that dependency myself and hence do a test. And absolutely what I don't want to do is something like if test mode in here, because that sort of code gets left in operational code and causes havoc further downstream. I want to leave my operational code completely unchanged, except I don't want dependencies embedded within the code. So step one is to split out this as an interface. So I'll do that now. I'll have an iClock interface. So I've got some prepared stuff here, so you don't need to sit and watch me type. So I've got an iClock interface here, and what I'll do is, when I create my message of the day in the constructor, I'll pass in a clock and store it here, and then at this point here, if clock.hour, that's proving it's a live demo. No mistakes means it must have been recorded. So if this interface, notice I'm hooking into the interface here, not into a concrete class, it's less than 12. So far I haven't really changed very much. And of course, now I can't create a class without passing this in. So a paradigm that one often uses is to have a default constructor which constructs the operational version of this, which is my system clock here, which, big surprise, goes and uses the system clock. Especially if I put it in the right place. Is that in the right place? Yes, it is, yeah. So hopefully we're compiling. We haven't changed anything. The tests will still fail in exactly the same way as before. But what I have done is I've factored out this dependency and made it into something that I could maybe pass it in as a dependency injection. What I'll do is I'll do it a bit clunky and manual so you can see where mock objects fit into the game plan. Because what I can now do is, over in the testing side of things here, I could pass in an object here. And what I might choose to do, and as I said, it's going to get a bit clunky, and here we go. I could create a couple of classes like this. A morning clock that returns 10, and an afternoon clock that returns 15. And pass in this, I use the constructor overload. So we'll have a morning clock there and an afternoon clock here. Compile. This is because these errors are because mock-Q, which I'm about to use, also redefines, doesn't redefine, it's the same thing for a couple of the things in the system namespace. I thought I'd solved that, but I don't need to solve it right now to get the point across. So now, having taken control of that dependency, I've now proved that my operational software is correct without resorting to any test code in line at all, which is brilliant. And you're probably thinking the same as I am. Well, it's a big price to pay. All of this stuff here, which I've shown only the tip of the iceberg, there's going to be a huge amount of that. Really, to do this, to get that 10 in sort of here. Probably more appropriate to say to get the 10 in there. That's really what I want to do, is to say if anybody in this message of the day greeting, I hear, ever asks the clock interface, what's the time, give them 10. So the overhead to get those two characters in there is another whole slew of classes to do that. Surely there's got to be a better way. And yes, there is a better way. It's called mock objects. And mock-Q, as it's pronounced, is the one that's current in .NET, and a very good thing it is as well. So what I want to do is to construct a mock clock. This is purely in the testing side, doesn't exist in the operational side. And I want it to say, you will flake up a response whenever anybody talks to the clock interface. And the response I want to give you, clock dot set an expectation, is if anybody calls you on your hours, then give them 10. Likewise, down here, give them 15. And then pass this here as an overload into here. And it's a little bit unfortunate because this actually isn't an iClock as we had. This constructor overload takes an iClock. There we go. And unfortunately, I've understood that there was a vote in the C# compiler, sort of public vote as to which way they should jump on a particular issue, a sort of secondary issue, but it had the consequence that mock-Q, with mock-Q purely in the testing side, you have to do that because it didn't get enough votes to make that problem go away. As I say, it's only in the testing side, never features operationally. So we'll have that again over here. Where are we? This is the day, isn't it? Got my brackets right, looks hopeful, and so now we should have these as being redundant. Let's make sure we compile. Yes, we're off. Try a test. And we're working now with mock objects, faking in what's going on, so without the need to do this. And this is a very, very common way. We flip back to the slide of injecting what the second in line is going to return for certain conditions under test. Just before I finish with the NU bit, I said there was one thing I preferred NUs over MS Test for. I'll just show you that. Because one thing you should adopt in your software is to relentlessly remove duplication. And here we've got some duplication. In fact, the only difference between the good morning and good afternoon is the 15, the 10, and the message. Could we not parameterize that? And the answer is yes, we can parameterize it. We could do something like this. So what I've done is I've parameterized the expected result and the hours. So these elements get passed in here. This is now covered because this is effectively two tests. If I run it, oops. And off we go. So that's the feature I like of NUnit, better than MS Test. The feature I prefer MS Test for is if I make a change here, say I put that down to 10, so in other words that test should fail, and I run it again, then the test passed, and you say, well, wait a minute, I just changed that, that should fail. NUnit doesn't have the same level of integration with Visual Studio as MS Test does, and so when you make a change, NUnit doesn't recognize the change and force and compile. MS Test does, so slight benefit to MS Test on that one. So hopefully you've got an idea now as to what mock objects are, and some companies use them just relentlessly to mock up all of their sort of second-in-line software. If you're just moving into UnitTest, my recommendation would be aware of mock objects, get used to some UnitTest first, and then start to play in the mocking game. So that's the net result of mock objects. You don't need this software in line or available. You fake it up over here. So there's the sort of unit test code you've just seen. And I just created a mock. In this case, this was the chess game, so I mocked up the game interface. It has to be done by interfaces. And the net effect is, of course, that you refactor your code to remove dependencies and convert them to interfaces. And actually, that's a process that we call design. Removing dependencies is what design is about. So how does it encourage good design? Well, the requirements and dependencies, yes, that's all part of it. As I've just described, an important part, equally important, if not more important, is the refactoring. That the whole reason that we adopt unit test is so we don't sort of wander off paint ourselves into a corner with our design and find that we have to apologize for it a couple of months downstream, that we want to keep it fresh and make it available to convert into whatever the next requirement is coming along. I don't mean a future predicted requirement, I mean a hard requirement, but we encode them, we solve them one at a time. I guess if we were all Mozarts and we just produced perfect code and perfect designs first time around, there'd be no need for most of the software that we see around us. We wouldn't need to test it either. If you're one of those, then I guess my only request would be that if you happen to be working on a nuclear power plant safety system in the vicinity of Edinburgh, just drop me an email because I'd be interested in that. Okay, on we go. It's all about dependencies. And here's a dreadful diagram. I know I've drawn lots of these sort of diagrams myself in my early days and didn't really figure out what was wrong. The dotted line in UML means dependency. It means if you change this, this suffers. This dependency means if you change this, this suffers. In fact, in .NET, you can't build that because this says you have to build a presentation layer before the business logic because of that dependency. Sorry, because of that dependency. And this one here says you have to build the business logic before the presentation. In other words, you can't build either. The dependencies should look much more like that. The business logic gives a contract out to the other components and says, this is what you have to conform to. You do that, and we can play ball together. So one-way dependencies, two-way traffic flow. So with those sort of things out of the way, let's have a look at some sort of common GUI patterns and see how we get on. We've done the mocking. First of all, the smart client. As I say, this is the one that's been around since the 90s, and the model is, as shown here, what you've got is the Windows forms, ASP.NET web forms, even WPF. If WPF done out of the box, it's the IDE sort of encourages you to do this. So what I've done is I've done the same small business problem across 4 types of user interface pattern: smart client, model view presenter, model view controller, and model view. Sorry, people say MVVM, model view model. So I'll, to save a bit of time, just for the first 2, I've prepared the starter with the dependencies. Well, this is the dependency, by the way. So let me show you what I mean. Let's prepare my stuff. There we go. So first of all, off we go with the smart client. And what I've done with this one, the only preparation I've done is to create a web forms project and a model project in the same solution. I've put a reference from the web forms project into the model project. I don't actually have any class yet in the model project, and I've just got a web form in here in the view. I've called it view presenter because really what's going on, as we'll see, is that this bit here, when we look at the model view presenter, you recognize what's going on here as a combination of the view and the presenter. So in this solution, I've called it my view presenter. And I don't know if you've come across this. It's new in 2013. I don't remember seeing it in 2012. What I've got is a reference from the model, sorry, from the view to the model. And wouldn't it be nice if we could see this dependency here reflected from our add references? Unfortunately, it's not quite, doesn't quite do that. So if we produce excuse me, a dependency graph, it's quite a neat little feature, this, but it works off the relationships in your code rather than relationships that you've added through address. So we don't need the externals, and it hasn't got the line between them. Bit of a pity, but it'll have the line shortly once we put in some meat into this. Excuse me. So let's get started. Over on the model, and we have a model. I've called it model or stock BL for business logic, because we'll see in one of the later models, one of the later patterns, sorry, that there is a split between the business logic and, if you like, the adornments that go on top of the business logic. Not true of the smart client. So here's my stock, and what I'll do is I'll populate it thusly. So I've got some stock, some simple property here, items in stock, and then you can increment and decrement stock. So these will be eventually hooked through to controls on the page, and some logic that says reorder levels, like that in here. And I've sort of regarded this as a bit of an adornment on top of the essential business logic here. Maybe in this case you would argue, well, actually this is part of the business logic too, but if you can view it as an adornment, it's going to help in splitting out where the difference between the view model and the model when we get to the last part, the MVVM. Okay, so we've got a stock business logic there, and what we'll do is we'll have a user interface. So in here, drag and drop. I'll do drag and drop the easy way by copying something I prepared earlier. So we've got a couple of buttons and a text box. So what we can do is increase and decrease stock. And this text box here should show the current stock value and then the color to say whether it needs replenishing, whether it's okay, whether it's gone negative. And we'll fill in the event handlers. I should have added early on in the talk, I don't believe I did, is that I remember when I started patterns that I read the books, I intellectually went through the exercises, but it didn't click. And it's only when you see the code in front of you and you probably in a bit of quiet time as well, that suddenly the penny drops and, oh, of course, that's what they mean. So that's why I've given over a lot of the presentation to going through a sort of build it up from cold demo, such that you can follow the thought train of how the bits are put together. So I should now have a couple of event handlers behind here. There we go. And what I'll do is I'll talk through to my stock here. I'll use a little idiom that's very common in the web side of things in .NET, a property to represent my stock. So what I've done here, because I want some persistence of the stock rather than going back to a database, I said, well, I'll just bung it in session, such that the stock isn't 0 on every pass of the page. And what this little property fella does here is it encapsulates the design decision that I'm using session. So if I change my mind and decided to put it in a database or put it into view state or something like that, then the change is limited to just here. So here's my stock. And what I want to do in my increase and decrease is exactly that. So call through to my business logic. So notice it goes straight through to my business logic. And it knows what to do on the user interface. So this is a combination of telling the model what to do and then saying to the model, I know what you've done, and I know how to display this on pretty much know how to display it on the page. The benefit here is that the change color, this little procedure here, which I'll drop in, that truly is view type of material. What color shall I show for stock replenishment? And that is truly contained in the view and doesn't leak through into the model. So let me put the decrement stock in as well. And it looks like we need a bit of a system drawing. I must have put in the reference to it. And compile. So we've got a couple of controls here on the page, referencing a stock held in session. And as it goes through the values of, I can't remember now, is it 5 and 0? So the color should change. So let's have a look and see if it does that. And can you see the architecture? It's probably as simple as you could get. And you could almost count it as an invented in my garage type of pattern. Good for if you're getting started and you want to knock up a user interface. You're not too concerned about whether it's still going to be useful in 6 months' time. Think of it as that type of situation. And there are projects that do that. I did one myself, not so finished it about a month ago. And the smart client was exactly what was needed because this didn't have a future beyond about 3 months hence. But if this application is going to be still around and running and being asked to be changed, more importantly, in a year's time, 2 years' time, then the architecture we've got here is likely to result in a lot of repetition of things, a lot of business logic leaking into the view area. When it's asked to go out onto a mobile phone as well as onto a web page as well as onto a Windows Forms, we'll find that some of this stuff here gets repeated in each of those technologies. Let's have a look at the dependency graph because we're now talking to the stock business logic. There we are. And if we did the dependency graph again, we should see that we have the model as so we have to get rid of the externals. So there we are, the view talking to the model. And what you can do with this is you can expand it and it'll tell you exactly which bit of which is talking to which bit of which over here. So the marks out of 10 is really pretty good here. Okay. So the smart client. Let me leave that around because we'll find that this thing here, the stock, will reuse that. So here's the model again shown in PowerPoint. Front end model adornments typically go in the model, and it's really used for stateful type of things. And I call that the view presenter. Excuse me. So the model view presenter is a development of that. Again, I've prepared one here to save you watching me type in the essentials. And what I've done with this model view presenter project is hopefully replicate what we've got here. So we'll have a web form view. We'll have 3 class libraries, an interface, a presenter, and a model. The model is pretty much as before, has the model adornments in it. So in other words, it's a business model with stuff added to it. It's not pure business logic. And the presenter takes responsibility for what we saw in the view previously of saying, I know what the model needs to do, I know what the view needs to do, and I'll tell both. And so the view gives the stimuli through to the presenter. The presenter needs to talk back to the view. And the way it would typically do that is through a view interface. So there'll be some methods in here that the presenter will initiate and the view will implement that interface and get the result out on the view. So let's see how we get on. So just to show that we've got the right things in place, what I'll do is put in just some dummy references, like for instance this, talk through to the presenter. The view also talks through to the interface, so it implements the interface. Stock view, I think I call it. I did. Hasn't got any methods in it yet, so if we did an implement interface, it's actually not going to do anything for us. The presenter, in its turn, talks through to both the business logic, the model, and to the interface. So we'll put in a bit of that. Solve the references. Always look at this because the default, if you can't find it, is to generate a new class view, which is almost never what you want. So hopefully we're talking now and we should be able to see the essential pattern before we actually put any code in. So get rid of the externals, line it up a bit, So stock view, there we go, presenter. So it looks like we've got the right relationships in place. So now we'll add in the code into these fellas. So as before, the stock is exactly the same as we had previously. So what I'll do is I'll pinch this one I've got here and drop it in. So that's exactly the same as we had just now for the smart client. We need to, because this is used for stateful things, we need to make sure that we're still on the same instance of the stock. And so I'll have a little stock factory with a singleton embedded inside it, such that when we go to the stock factory, we'll always get the same stock instance out of it. The interface consists of the two things that we're writing back to the screen. So my stock view interface consists of those two. Looks like we need a reference to a drawing. And green, yes. And the view, again, exactly as before. Here's my view, and I'll put in a couple of paint handlers. Okay, and in the code behind, what happens is that we wind up a new presenter. So we'll have a presenter here. We wind up a new presenter and then delegate everything through to the presenter. So the two methods we got, the increase and decrease stock, they go through to the presenter, and the presenter decides what to do with them. If I was doing this for real, then I would certainly do this and then do a right-click, generate method stuff, and we'd find those would be sitting there waiting for us in the presenter. And then implement the interface. We've now got a couple of methods in there, so we have this selection available. There we go. And these, of course, would write to the screen. Compile it. I still need some stuff in the presenter. So my presenter needs to hook itself into both the stock and the so it needs to reference the stock using model, yes. And it also needs to have the ability for the page to subscribe to this add thing here, such that the stock view is populated and the presenter can talk back to the page. I must have used a different model, so model run, model project. There we go. And the code in here, you'll recognize as in the increase stock as being a sort of amalgamation of what we had before. I know what to do with the stock, I know what to do with the user interface, and I'll take responsibility for doing both bits. So that's what the presenter does. It's a combination of model work and view work, and a bit of change of color. Now we don't. We need a reference to. This is one bit I really do like about Visual Studio 2012 and onwards, is the search box in here to save you searching for things. And if any of you are wondering what I'm doing here to put in that, just put in that line there, the using statement. It's control dot, the most useful key sequence in the whole of Visual Studio. Okay, so I think I've got all the bits in place. We've got a view. It's got some buttons on that talks through its code behind, passes them on to the presenter, and the presenter does what's necessary by passing on to the model, and then talks back to the view through the interface, and the view implements the interface, and the implementation is to take the results here and put it onto the screen. Let's see if we work. Like I don't have something quite set. I'm sure many of you on the call would have spotted what I've done wrong. Let's have a look. Can I do it just by inspection? I must have missed off the creation of. I know I haven't added the presenter to the view to the presenter. I said I would. I lied. I forgot. It should be in there. So the view needs to subscribe to the presenter such that it can talk back. And the error I was getting by the look of it was trying to do something like stock view dot set stock value, and this was null. Hopefully, we shall see. So there we go again into OK stock, replenish. So it works. And it's got a little bit more architecture to it, and it's not a bad architecture. Not a bad architecture for things which are stateful. It's a lot better than the smart clouds. Let's put it that way. Okay, so that's the smart client and the MVP. So hopefully you're okay with that, and you can see that all the smarts are in the presenter, both the what to do with the model and what to do with the view. Let's go on to the model view controller. And actually the model view controller should really be called, I think, what's it, RCVM. That's it. Yeah, RCVM. Oops, I'll bring a notepad across onto the screen here. Well, there we are. Should really be called, in my view, RC. It's a bit of font on here, shall we? Because the essential thing is the router. You don't get anywhere in Model View Controller without some sort of router involved. So when we get started, I'll show you the router. And by default, if you just put in the router and nothing else, you'll get a 404 error, meaning it's looking for a controller, can't find it. So really the minimal you've got of Model View Controller is router and controller. The controller takes responsibility and returns the stuff to be displayed. Whether it uses a view or whether it uses a model, that's entirely up to the controller. So the controller could return a string. And in a simple MVC application, that's I mean a very simple one. That's what it would do. Next up is probably the view. That the controller quite often passes responsibility to the view to say, look, you know about HTML, you know how to construct these things, you go and do it. Give me back what you've done, and I'll give it back to the client. That's why the class diagram, or the dependency diagram rather, for MVC, it's not view going back to the user. The controller decides what to pass back. It often is the view, but it's the controller's decision. And then the view might be, typically in MVC4, it is bound to the model. So you get a type binding here, as we'll see, and the controller can also opt to use the model. So for me, it should be called RCVM. Let's have a look and see what's involved. So don't have a prepared one for this, so I'll do it from cold. And this is how I did the other project. So you see the route, but hopefully many of you have used Visual Studio before will recognize the sort of things I'm doing. That you start with one of these, another project type, which I'll call, what should we call this one? MVC demo, how about that? That gives me the solution. To the solution, I'll add a new project, which should be a Visual C#. Notice it defaults back to VB. I've fallen for that one before. Web 2012. So we'll have an empty MVC application here, which I'll call MVC project for consistency with the other things I've done. And so there's no prepared stuff. We'll have as empty as it gets. And we'll have our model. New project, Windows, class library, model. Project. Okay, and the controller. Notice the controller, the model, the view, of which we have none at the moment, are all sort of parts of the MVC project. When the MVC talks about model, it talks about the one that we put in here, which is like the business logic model, plus any extras that make it compatible for the view. It's like a sort of model on the fly almost. When we get onto MVVM, it's very much like the view model that we see in the MVVM. So when we get to the MVVM, I'll recall the model here, but that's what the MVC terms the model, which is why I called this one here the model BL, the business logic. So let me put in our business logic. We always dump the starter class anyway. The reason why we do that is not because there's difficulty with the class, but there is with some bits of web forms where if you rename it rather than delete and start again, it won't rename all the bits. So C# class stock business logic. And in here, we will just have the essential business logic of what's going on. So management of the stock and the ability to increment and decrement it. So I've moved what I call the adornment, the rules for replenishment. They'll be outside. They'll be in this model area here. Okay, did I add in a reference to the model? I didn't. So we'll add in a reference to the model. And hopefully we're in business so far. So, as I was saying, the essential model view controller is just a router. So at the moment I don't have any controller. What I do have is a router, which is saying if I don't provide any information, if you just go, then I'll look for something called the home controller. But in this router here, it will add in the word controller for you. So that will refer to a class called home controller, looking for a method called index, which I haven't got. So if I start this, so I haven't got either that or that. If I start this, we should get a 404, which is, if you like, the R bit of my rebadging of the MVC model, saying we've got a router, but we've got no controller, game over. Let me put in a home controller. And where are we? Add controller. So we'll add in a home controller like this, and as I said, if we wanted to, we could just return a string. And there is an absolutely minimal MVC application. Doing that. So probably hasn't got much of a future. So let's go back to where we were, put in a view, right click, add view. So notice it's done by convention, so the view for the index will be called index and live under the views folder. I won't explain these right now, but we'll just get some HTML in play. There we are. And we put in something like this. So we'll have a couple of buttons. We won't have any stock data yet. And this is an HTML helper. I've put in a home controller. I actually meant to put in a stock controller, but stock controller would be. Let me put in a stock controller because it's more meaningful in this example. And stock controller. So this would now go through into add view. And I'll put that HTML in here instead. And of course, because the router now needs to steer things through to this area, this particular class, then I'd need to do a bit of this. Stock controller. Okay, how are we doing? We have the one we want is that one there, which is this one. Let's go with that one. So a couple of buttons. We don't have any stock in there. Let's see if we have any action yet. So at least we've got a view display. So can you see that the view can now take responsibility? So this file here takes complete responsibility for what the HTML is going to look like. Again, we're going to need some persistent sort of stock. So I'll put this in place. Where are we? Stock control. And I think this should be stock business logic throughout. No, my mistake. I was slightly ahead of myself. Let me come back to that in just a second. But I meant to put in the model stuff first. So we'll have a model over here. Right click, add class. And this model is going to be called, what did I say I'd call it? Stock, hopefully. I'll call it stock. Different from the stock BL that exists in the proper business logic area. And what we're going to need to do in here is to hook it through to my business logic. Something like that. So I create the stock and pass a business logic element into it, and then from then onwards, the stock, when it can do, delegates back to the business logic for the for the stuff that is not delegated to within this model. So that's these things here. So they go straight back to the business logic. And then the adornments, the stuff that is on top of the original business model, which I've classed as being the replenishment logic. Something like that. And the stock level. Stock level. So back to the controller. How are we doing? So that's coming through to the project models. That's the correct one. So this is the models folder here. And this one is the business logic. Hopefully I haven't just inadvertently added in. So I hope that's right. I wasn't paying enough attention when I clicked the button. Let's see how we get on. So what should now happen is that when it comes in here, it should come into the index, go into the view. There's the view. The view will eventually be hardwired into the model, and we should get some model sort of data out there in a minute when we replace that. Let's just make sure we haven't broken anything so far. So we've got all the bits in place now, very nearly all the bits in place. So what we need to do is to hook it through. So index, not a particularly good name. So what we'll use here, I'll do change stock. And create the view for that. And what we'll do is we'll use a strongly typed view. We'll go through to our stock. Right? And the effect of that is to put in this line into our view, which means we can data bind to things in the model, which is a real big bonus of MVC, is that you get this data binding that's the model binding, we call it, really gets you a long way. And that's going to need another one as well to pick up what's on the button. And notice that we've split them apart, HTTP post, so this would be an HTTP GET. And if I've done this correctly, then what should happen is that it should pick up the ink or deck on the button and send it through to the business logic. I need to get on to the MVVM story, so I probably will need to leave this in a little bit. I'll put the completed version into the download. And looks like 404, that's because I changed this to a stock controller and the method was change stock. And what I didn't do was tell the router I'm now interested in stock and change stock. Something like that. So I think I must have screwed up my view somewhat. But hopefully I've got one here that I prepared earlier, so I can just show you how it should have ended up. Let me see. Here we go. Yet again, proving it's a live demo. Mistakes are made. I apologise for that. So this should be very, very similar to where I got to, but unfortunately I must have done something having one eye on the time here. So we've got the views, the stock view is, and I put in some variations enough stock and change stock and so on, just to show that if you wanted different types of views, you could have multiple views for one stimulus coming in, and hopefully this should do the business. So we wind up and decrease stock. And so apologies that you didn't see it through from cold, but we nearly got there. We just missed off a little bit, and I'll figure out after the event what that is. Don't want to eat up your time now. Back to the PowerPoint. That's what we've just done. The controller view model combination, of which the router is not part of the MVC, but it's very much there as the first bit, the R. And the view doesn't itself go back to the user. The controller decides to send the view back to the user or not. And the controller can decide which view is appropriate given the situation. Okay, and on to the last one. The MVVM, the one that came along with WPF. I see we're sort of getting, what are we about, just gone quarter past. So rather than build this one up from cold, I'll show the prepared demo and talk you through some things. But the essence of it is this dependency here, that the view model has got absolutely no dependency back to the view. You remember when we did the MVC, we'll go backwards. Sorry, the MVP, that the presenter needed a view interface to hook back into the view. Well, what happens in MVVM is that we use the magic of data binding and commanding, such that the view has a reference to the model has absolutely nothing to do with the view. Doesn't even know the view exists. But what it does is it produces stuff in such a manner that the view is able to consume it. It uses the paradigm is the model pushes the information back into the view using an interface in here called iNotifyPropertyChange. That looks after the changes of data. The stimuli that come in here go into the model by virtue of a command pattern. And part of the command pattern is to say, well, should this button be enabled or should it be disabled? Well, in other words, traffic going over this way. And the command pattern looks after that. So I'll point out the salient features of those two. Yeah, let's take it away. So just make sure we got the architecture correct. Compile it first. Yes. So a good WPF project should have nothing, or virtually nothing, in the code behind. It's strange that almost everything that's good practice in Windows Forms is bad practice in WPF, but it works. And it does take a little bit of time to get going with WPF, so if you're moving into the WPF area, expect the learning curve to be difficult. But the view, which is this one here, shell, actually just has text statements that refer it through to here. Oh no, not true. It does actually go and create the view model. I'll show you that. But the binding is done by text statements. But the important thing I want to show you here is the view model has absolutely no awareness of the view. The model has absolutely no awareness of what's going on here. The dependency is definitely left to right, which means you can chop this bit off. You can fake up this bit by using those mocking objects that we saw earlier and test this as if you're testing the user interface, but you can do it automatically. You can use NUnit or MSTest to just have UnitTest going all the time with this and produce this that satisfies your business logic and your business problem. So what are the salient features? First of all, the view, which I've called the shell here because that's the way it works. If you use Prism, they call it the shell. In the shell, what would happen is you have user controls. There we are. So I've built this user control, which is a separate project here. This view model project here, which contains not only the view model, but also the user control. This XAML here, XML for applications, is the user control. A little bit of time to load, but there's the user control I built in this separate project here, and then dropped it into the main window. If you're using Prism, then you'd expect to see things like regions that do that work for you, but I've used a sort of non-Prism version here. If we look at the code behind the stock view, then apart from this one line here where it says create me a view model, there is no code behind. The way that it talks through to the view model is through the magic of data binding, things like that. Make the text on here bind, excuse me, make the text on here bind through to the items in stock. And the way that MVVM does that, it's not like a requirement, but it's just so commonly followed that I'd highly recommend it, is that it's actually very easy to get into a mess as to, well, which is the path on here? So am I going to this? Am I going to that? Which class am I going to? So the paradigm we use in MVVM is this one here. Where's my... is the data context always goes through to the view model, always. And that means that any binding statement you've got in here, this path, must be a public property on the view model. So if we look on the view model here, we would see a public property. There we are. It can't be a public field, it's got to be a property called items in stock. And because these sorts of things might change, we needed a means of notifying the view that things have changed, so the view better go and update itself again. Remember I said I notify property changed? Your view model would implement I notify property changed. What does this involve? It involves a standard bit of code, those half dozen lines there. This is actually the interface, just that event, outgoing interface, but you always have a common procedure called on property changed that fires that interface, fires that event, and often you have this in a superclass. So your view model would be derived in here from a base class that would contain your notify property change. And the deal is that when you know that some data has changed that the view should be aware of, you signal to it like that. I've been a bit lazy here. What I should really have done is that to say this property, items in stock, that's the one that's changed. That's the only bit on the user interface that the view needs to update. So WPF is geared at big interfaces where, or WPF and MVVM is geared at big interfaces where small, relatively small chunks of data change on that interface, and you don't want to just do a client's invalidate and redraw the whole screen when maybe only 10% has changed. So we've got a view model which may have derived from a base class. We can use that. Either way, it's got to implement notify property changed. The other connection between that and the view is this fellow here, the command. Unfortunately, one of the limitations of WPF is that the inbuilt command climbs the WPF tree, which means it has to be in the code behind. So the handler for it has to be, oops, where are we? We've lost it. There we are, code. The handler for it has to be in this class here, which sort of negates the whole benefit of it if you're using an MVVM type of style, where the view model is taking responsibility for handling all of the stimuli coming in. How do we get around that? Well, there's we invent a type of command that is independent of the WPF tree. We'll see that in the view model. It's called the delegate command. I passed it. So implement side command implemented by this delegate command, which actually comes from the Prism DLL, so the Prism download. There's another one, the relay command. The delegate command is the one that's used with Prism. And so you have that combination of things occurring in your view model to handle stimuli coming in from the view, and you have no code behind in the view to handle that. The view model itself hooks through to your business logic and hence sends information where it can straight through to the business logic like here. And it doesn't take responsibility for knowing how the view responds. It takes responsibility for saying, view, you better do something because some of the data you subscribe to has now changed. And notice that in the view model, the model adornments go there. So the view model in MVVM is like the model in the MVC. Both are different to the business logic model, which is what's used in MVP and in the smart client. Tumbling to that is one of the sort of aha moments in recognizing the difference between the MVC and MVVM patterns and the MVP and smart client patterns. They redefine what they mean by model. Okay, the difference between the view in the MVC and in the MVVM. In the MVVM, the view is constructed like this. It's almost like your logic is sort of unaware of it. It's a separate activity to the view. In the MVC route, the view is something that's called by the command, by the controller, and the view hooks into the MVC model. So the view is a more integrated part of what's going on in MVC. In MVVM, it's definitely the front end. You can cut it off with a pair of scissors, and nobody in the view model will be any the wiser. Okay, let's see if it works. Hopefully I left it in the working state. I think I put some logic in whereby it locks out after a time. I'm not just making that up. Oh, it looks like I haven't got in the red logic. I'll have a look at that. Yeah, I think the way I had it was once it goes negative, then game over. So in other words, I put in some extra logic to do that. Okay, so we're bumping up to 4:30. Just to recap over those models, and we'll split back a couple of slides. So the smart client, where you just have two elements, great for very small, non-long duration projects that you don't expect to win accolades in years to come. The model view presenter, geared really at the web form and the Windows forms type of application, where the data is persistent and the presenter effectively has a connection back to the view through the view interface. The MVC, where the controller is king, with the router as well, so the router control combination is king, and they decide what they will make of the model, of the view, etc. And the view doesn't have a direct relationship with the user. The controller decides which view to call up, what model to give it, and to say, well, off you go, build me a view, and I'll pass it back for you. And finally, the MVVM, excuse me, which should really be called VVMM, so VVMN, but it's not quite so catchy as MVVM. So in the MVVM, everything is independent. The dependencies are purely going to the right-hand side, which means you're completely unaware of anything happening to the left of you. It achieves that by the magic of data binding and commanding in here and by events in here. Very much geared to the WPF situation. For my money, I wouldn't do a WPF project without MVVM, Prism, and Unity. That it's just so easy to get into a mess. The model view controller, because of the way the IDE steers you into the right things to do, it's more difficult to sort of go off track. Okay. So, I think we're pretty much at close out here. So this is what we covered. Hopefully you've got an understanding of the range of things now, and go away and apply them to your own problems. A housekeeping slide, just as I'll leave this up, just in case you need to make a note of the Tech Week email address or my own email address. Feel very free to drop me a question. And I think that's the last slide. It is, yes. So apparently the mailbox is wrong, but I think from what I'm seeing here, it should be that. Apologies. There we go. Okay, so thank you very much for listening. Friday afternoon is never a good time to stay on, but hopefully it was a good investment of your time, and hope to see you on QA courses in the future. Okay, so back to you, Sam.
Thank you, Paul, and thank you, everybody. Just one last bit from me, and that's just to say that when you leave the session, our QA evaluation survey will launch. I really appreciate you taking a couple of minutes just to complete that for us and tell us what we did right. Have a lovely weekend, and thank you very much.
Thanks, Sam.